Everyone, welcome to our play posit for today. We're going to be covering 3.7 through 3.8. So go ahead and grab your notes. You're going to want your notes from 10:27, our last live class together last week, and then also the notes from today. So go ahead and have your play posit graded assignment open and let's get started. So another reminder, don't forget that our end date is this Friday, November 6th. I know we've talked about this a bunch, but I just don't want anyone to forget that you will want to go ahead and complete any assignments that have zeros. So you don't want to have any zeros come Friday. And also, you're going to want to review and retake any low graded assignments because after Friday, you will no longer have access to those graded assignments. Now, you'll still have access to the material to review it and go back and all of that, but you won't be able to use any of those attempts left on any of those graded assignments. If you have any questions at all, send me an email. So just another reminder, I know we talked about this, but if you looked ahead on your plan, you'll see I gave you no new or extra math work on Thursday or Friday. You actually will not even have a Class Connect quiz on Friday from any of your teachers. We're not going to be doing that since that is your last day. So for math specifically, you're going to have these 2 days to sort of just tie everything up and get everything in order. So hopefully you don't have too much backlog when it comes to this week, but I did want to give you some extra time in there. So use it wisely. All right, so today we're going to finish our notes from last week. We're going to be graphing systems, system word problems, and we're going to write equations from graphs. We're going to go backwards. You'll see what that means. So again, these are the notes from last class from 10:27. So if you do use the guided notes that I provide, then you're going to want to go ahead and grab those. If not, then you're working in your own math binder on your paper. So you know there's a few ways to graph lines, right? We've talked about using the slope-intercept form, y equals mx plus b. Remember, m is the slope and b is the y-intercept where it crosses the y-axis. You could also use a table of values, right? Where you pick any value that you want, you plug it in for x, and you get out some y. Or we can also use the calculator. Ooh, we can also use intercepts. Remember we talked about intercepts where the y-intercept is when x equals 0. And the x-intercept is when y equals 0. So we have these 1, 2, 3, 4 different ways to graph lines. So if you look at this example, it does have y first, right? So we're thinking it's in slope-intercept form, but when you look at it, there's no slope, right? There's no x term. There's no number with the x. So there is no slope. So think about what a line with 0 slope looks like. So you could also think of this as 0x minus 4 because there is no x term. So we could put it in with a 0. So a line with a slope of 0, what does that look like? We can use our -4 as our y-intercept. So we'll put a dot right there at -4. So this means whatever you pick for x, it'll always be -4, right? What if we put in a 1 for x? Okay, we'll put in a 1 here. Oops, this is 0. Put a 1 here for x, and you get 0 times 1. That's 0, and you get -4. All right, what if we put a -1? Well, -1 times 0 is 0, and you get -4. So no matter what you put in for x, you're always going to get -4 out for y. So let's plot these 2 points. 1 comma -4. -1, -4. Hopefully it's doing what you thought it would do behaviorally. You're always going to have the y value of -4. So a line with 0 slope is a horizontal line. I'm going to put in a line here. A line with 0 slope is a horizontal line. So this is going right through y equals -4. Excuse me. Okay. So now we just have to decide There we go. We just have to decide which way to shade the solutions, right? Because this is an inequality. So I like to pick 0, 0. You guys can pick whatever you want. We're going to plug it into the original inequality. So 0 is greater than -4. Is 0 bigger than -4? We can look on a number line. Sure enough, the further you go to the right, the bigger the numbers are. 0 is bigger than -4. So that means that means 0, 0 is a solution. So we want to shade over the solution. So it's going to go all this way, above the line. We want to shade over the points that work. So if we were to pick any point in this orange region, it will work in the equation, any point. What if you pick -2, 5? Plug in 5 for 0, 5 for y. Is 5 greater than -4? And yes, it is. So this point right here works. All right, let me show you guys on a on the graphing calculator. So we want to go to our Desmos graphing calculator. I should have it. I don't know why I don't have it earmarked here. I know you guys do. We've talked about it. Okay, so we're just going to type y is greater than -4. And there it is. So you can see here, because it's just greater than, it is a dotted line, right? We're not going to include the value of -4, but it did shade all above the line. So we should go back to our line and make this dotted. Wonder if I can easily dot a line. I don't think you can. So I will draw it by hand. It's not going to be as pretty, but you get the idea. So calculators can definitely come in handy to double check things. You guys can use them to graph lines. So let's try the second one here. This time, x is first. So there's no y value here in this equation. So x is always going to be -5. Here's the x-axis, here's -5. No matter what, x value will always be -5, no matter what we do. So this is a vertical line, and this is also going to be dotted, right? Because it is just less than. Now let's pick a test point. Here's 0, 0. So 0 is x. Is 0 less than -5? No. So that means 0, 0 is not a solution. So we need to shade the other side of the line because we want to shade over the solutions. So it's going to be this side. Let's double check it. X is less than -5. There we go. Shaded to the left, and it's going through the value x equals -5. All right, let's try these. So these are in standard form, right? Remember that very general, very basic standard form. We have ax plus by equals c. Now, standard form is really helpful to use x and y intercepts. So let's try that for this one here on the left. If we wanted to find the x-intercept, we would plug in 0 for y, right? So let's do that. 3x minus 2 times 0 is less than 10. 3x is less than 10. I'll divide by 3. X is less than 10 thirds. All right, so our intercept is going to be 10 thirds and 0. Fractions are totally fine. Remember we said that they're actually more real world than just whole numbers. So if you think of this value, 10 over 3, it's about what? It's about 3 1/3, right? That'll help us plot that point. So we're going to go over 3 and up a little bit, a third of that block. All right, let's find hold on one second. I didn't mean to go up. Let me undo that. Eraser. There we go. Okay. We're going to go over 3 1/3 and then 0 because that is our x-intercept. So let's find our y-intercept. We're going to plug in 0 for x. So 3 times 0 is less than 2y, is minus 2y is less than 10. There we go. We're going to divide by a -2. Remember, when you divide, it flips that symbol. I'm not sure why I'm writing crooked. I think it's my board. There we go. So our intercept is going to be 0, -5. Here we go. There's the y-intercept. So we have where it crosses the x-axis and the y-axis. Now we can just connect the dots. So remember, this is just less than up there in that original equation, so I'm going to do dotted lines. Now let's pick a test point. Let's try 0, 0. So if x is 0 and y is 0, what do we have? We have 0 is less than 10. Is 0 less than 10? No, right? Yes, it is. Oh my goodness, you guys, I cannot even talk today. Of course 0 is less than 10. What is happening? I had too much candy. Yes, 0 is less than 10. Maybe I was thinking -10. There's our number line. 0 is to the left of 10. It is less than 10. So 0, 0 is a solution. So we're going to shade over that value. We're going to shade over that point because it is a solution. Goodness. So now let's double check in our calculator. 3x minus 2y is less than 10. Here we go. It's a dotted line. It's going through 3 1/3 and 0, -5, and it is shaded to the left. Perfect. All right, now let's look at this one. You guys should totally try x and y intercepts on your own paper. Pause this and try that. And I'm going to confirm on the calculator. So 5x minus 3y is less than or equal to -15. Remember, to get the equal to, you literally just type it. So I did less than or equal to, and it pops it in there together. There we go. So our x-intercept is -3, 0, and our y-intercept is 0, 5. So we confirm that with what you got for those x and y intercepts. Let's plot our line. There we go. And this one is going to be a solid line, finally, right? Because it also includes the equal to symbol there. So here's our line. Just going to make it a little bit heavier so you can see it. There we go. And now we would typically pick a point, or we can also confirm in our calculator. It says to shade to the left. So that means any values to the left are going to satisfy this inequality. And you can always pick a test point. That's fun. There we go. All right, so now here's where we get to the systems. So a system of inequalities, or even a system of linear equations, involves more than one equation or inequality. A system has more than one. So here we have two in each of these. The cool thing is we're going to do them exactly the way we've been doing the others. You just have to do it twice on the same coordinate plane. And the solution to a system is where they overlap. Where the solution overlaps, where the shading overlaps. Because in order for a point to be a solution to the system, it has to work in both equations. It has to satisfy both equations. So if we're looking for the places that satisfy both, it's going to be where the shading is on both of them, right? So it's where they're going to overlap. Let's look at how that happens. So the first one we're going to do, let's graph that orange. We'll kind of keep it separate color-wise, and these are in slope-intercept form, so that's nice. Let's do it by hand. Y-intercept is -2, so we'll put a dot there on -2. And then the coefficient of this x term is just a 1, right? Whenever there's nothing there, it's a 1. So it's -1 over 1 is our slope. So we'll go down 1 over 1, down 1 over 1, and we'll make our line. Doo -doo -doo. I don't know why I keep saying do. I think I've been hanging out with my 5-year-old too long. Is that possible? Okay, this is a solid line, so we'll go ahead and put in our solid line here because it's just less than or equal to, so we're allowed to connect those dots with a solid line. And then let's pick our test point. 0, 0 is always a good one. So let's plug in 0 to the orange inequality and see if it's true or false. Is 0 less than or equal to -2? Remember, the further you go to the right, the larger the number. So -2 happens to be to the left. -2 is not bigger than 0. This is false. 0 is not less than -2. It's bigger than. So that means 0, 0 is not a solution. So we would not shade over that point. We're going to shade away from it, the other side of the line. So we're going to shade to the left on this one. So normally we would be done, right? Because we just graphed one inequality and shaded. But this is a system, so let's graph the second one. We'll do pink. All right, so our pink line, the y-intercept is a +2, and the slope is -5 over 1. So down 5 over 1. Down 5 over 1. This is a very steep line. Oops, it's up here. There we go. Okay, so now let's connect this line. It's also solid because of that equal to there. Very steep slope of this line. All right. Now we're going to pick our point, and let's do 0, 0. That's to the left. So I'll plug that into the pink line. And we get 0 is greater than or equal to 2. This goes away, right? That's just 0. Is that true? Is 0 greater than 2? No. So we do not want to shade over 0, 0. It's not a solution. So we're going to shade on the other side of the line. Oh, my mouse is not going to let me shade this part. That's funny. Well, I need to shade right here as well. So let's insert a shape. All right. This would work way better in New Row. So this is also our pink color. There we go. So we also want to shade that part. So where do the lines overlap in their shading? And that's going to be here in this triangular region down here. See, we have the orange and the pink. That is the solution to the system. If you picked any point in this triangular region, and of course it goes on forever, you know, it would work in both inequalities. So let's try graphing this one on Desmos, just to confirm, and I can show you what a system looks like on the calculator. Okay, so let's clear this out. We'll just click the X, and we're going to put each inequality in on a separate line. There we go. And then the second one, of course, you guys are hopefully double checking me. I wish we were in person. You know how sometimes I transpose numbers. There we go. So here's the thing. With Desmos, you can change the colors if you want. If you hover over this circle and you hold down the left mouse key, a color menu will come up and you can choose whatever color you want. I'm going to click and drag around and get closer to my solution set here. And here they are. That's where the inequalities overlap, that triangular region that we saw on our graph. So that means, again, any point you pick from this area is going to satisfy both inequalities. That's the solution to a system. Let's try the second one. That first line there, x is less than or equal to -3. You guys, is that going to be a vertical line or a horizontal line? Think about that. Remember when we just have an x term, what does that mean? That means x is always going to be -3. No matter what y is, x will be -3. So that's going to be a vertical line. And it is solid. Here, I'm just going to draw it. Because of that equal to there. Now let's graph the second one. So y-intercept of a +2, and then we'll use the slope. We'll go up 5/3. It's about there and there. All right, this is also a solid line. That's a pretty good line. And now we have to do our shading. So let's go to Desmos and see what we can figure out from there. You can practice using Desmos. And just confirming our work. There's that vertical line we drew right through x equals -3. And then here's the second one. I hope you guys are pausing during these times and actually trying to type them for yourself in the calculator. Just watching me, like, it's okay, but it's way better for you to do it yourself. So you can actually get the motion, see what it feels like, get used to it, get used to the buttons, all of that. Here we go. So it looks like the vertical line we're going to shade to the left, and our slanted line we're going to shade to the right. And there's where they intersect. That's the solution set for both of them. Let me get a different color here. So this guy goes to the left. And the other one goes towards the right. And it's not going to let me color over top that of the green. So remember, the solution set is where they overlap right here, this triangular region. Awesome. So now let's get to some word problems involving inequalities and systems. So this is, let's see, it's a little bit of translating as well, right? Taking English words and writing them as a math sentence. Kendra is making a large salad for a party. She buys lettuce for $2.25 per pound and tomatoes for $2.65 per pound. She spends at least $8. That's a very important word there, at least. Let X be lettuce and let Y be tomatoes, the pounds of tomatoes. So let's write this out. I tried to highlight all of our important information. If X is going to be the pounds of lettuce, how can we represent the total cost of the lettuce then? Here it is, it's $2.25 per pound. X is pounds, so it's $2.25 times X. Right? If it were 1 pound, you'd plug in 1 for X and you get $2.25. The second one here, the tomatoes is Y. So the total cost of tomatoes is going to be $2.65 per pound times Y. And that says at least $8. So what inequality symbol means at least? And sometimes it helps to talk it through. So it can be at least 8. Can it be 9? Yes. Can it be 7? No, it's got to be at least 8. So it can be 9, 10, 11, 12, 13. So it can be greater than 8. Greater than. But it's got to be at least. So greater than or equal to. Allowed. Hold on, no, not equal to, because it has to be at least 8. Whoops. Okay, there we go. Get my pen back. Greater than or equal to. It is allowed to be 8 because it's at least 8. So it can be 8 at least, or 9 or 10 or so on. So we did it. We represented this situation using an inequality, and that's it. They didn't want us to solve for anything, so we are done. All right, let's look at the next one. A supermarket employee is making a mixture of cashews and almonds. Cashews cost $7 per pound and almonds are $5 per pound. The employee wants to make less than 6 pounds of the mixture, but wants the total cost to be no more than $30. And I know there's a lot going on here. Let X represent the number of pounds of cashews and Y is almonds. So let's write this out a little bit. So X is the number of pounds of cashews and Y is the number of pounds of almonds. And I see two things happening here. Hopefully you guys too. I see the pounds because it wants it to be less than 6 pounds. And I also see money, no more than $30. So we're going to have a pounds equation and we're going to have a money equation, or inequality rather. So remember, X is the number of pounds of cashews and Y is almonds, but we want the total mixture to be less than 6, right? Less than 6. So the total mixture, how do we write total? We want the sum of the cashews and the almonds, right? So when you add the pounds together, they need to be less than 6. There's our pounds inequality. Now let's do the money inequality. This is very similar to this example where we talked about the cost when we're going to be spending at least $8, right? To find the cost, you had to multiply the cost per pound times the number of pounds. So that's the same thing here. The cost per pound is 7 times cashews, plus the cost per pound is 5 times almonds. And it says to be no more than $30. So we're going to have 30, but let's think about what goes here. No more than. So it cannot be more than 30. Sometimes when people see more than, they instantly write greater than because they think more. That's not the case here. We want it to be no more than. So it can be 30, it can be 29, it can be 28, 27. So we want this to be less than or equal to 30. But no more than. So we don't have greater than here because greater than 30 would mean that it could be 31. And that's not what we want here. So there's our solution. We wrote a system of inequalities. All right, a triangular region shows the number of possible ounces of gold, X, so gold is along the x-axis, and the number of possible ounces of silver, silver is along the y-axis, and these are in ounces, that a jewelry maker can mix together to make a certain piece of jewelry. So there must be this sweet spot where you mix a certain number of ounces of silver and gold together where the jewelry is stable enough to hold its form and to actually make a piece of jewelry. Which combination of gold and silver can the jewelry maker use? So they gave you the graph. This word can here, hopefully kind of stood out to you guys. Remember we talked about what is the solution to a system. This system happens to have 3 equations going on, or 3 lines, 3 inequalities, and they showed us the shading. Remember, the solutions are where the shadings overlap, which happens to be this triangular region here. These are the solutions. So sometimes in graphs, they're only going to show you the final solution. So if we went back to this, you wouldn't see the 3 different shadings. Like for example, in here, you might just see the solution as this. They would shade the part where they overlap versus showing you all 3 areas, the green, the yellow, and then the overlap. So that's something to keep in mind. Here is the solution to the system. So that means the answer to this is just any values that live in that shaded area. So what combination can they use? They can use You can use anything in here. And we can put up some examples. They can use what? 15, let's see. Let's do 10 ounces of gold and 20 ounces of silver. That lives on the line. It's a solid line, so it would count. You could also list it as a coordinate point if you wanted to, 10, 20. They could use this one right here, 15, 20. 15 ounces of gold and 20 ounces of silver. Anything that lands you in that triangular region would answer this question. All right, so now we're going to go in reverse a little bit. We kept saying that the solutions are where they overlap. So if you look at this example here, remember they're only going to show you the shaded region that works for both. So the solution to these two inequalities that are graphed lives right here in the pink area. This is the solution to that system. Just wanted to review that. So now let's write the equations from the pictures. This is a lot of fun. It's like a game. This is one of those times where we're not going to be able to use the calculator. So that's what I meant when we have the calculator as a tool, but we're not always going to be able to use it. So we want to use our knowledge of our slope-intercept form, I think. I think that's going to be the easiest way. Remember, we have all the different forms that you could use, but personally, I do think this is going to be the easiest. So if we're looking here at the solid line, we want the slope and the y-intercept. So the y-intercept is 2, so that's going to be the b value, right? And we have a y, so I'm just plugging in the numbers b and m. And the slope, let's get it from the graph. So we can pick any 2 points on the graph and try to get from one to the other. So up 2 over 1, 2, 3, 4. Ooh, so we can even go up 1 over 2. See that? 1 over 2, up 1 over 2. So the slope is 1/2, up 1 over 2. Now we just need to decide what inequality symbol goes here. So the shading is going to help us decide that. They shaded below the line, right? So that means that a point in this area is going to satisfy this inequality. If a point to the right of the line is going to satisfy the equation, let's pick a point and plug it in and see what symbol we need to make it true. So again, I'm going to pick 0, 0, even though you guys are probably like, that's not part of the solution. Well, it's not part of the solution to the entire system, no, but remember, if this line is shaded there, then it's also here. The entire right-hand side of that line is the solution. So we can pick any point that lives to the right. It's just that they're only showing you the part where they overlap. So I'm going to plug in 0, 0 for y and x, and I still have this square here because I do not know what inequality symbol is going to go there. So now, again, this is where I say it's like a game. Ask yourself, what inequality should go here to make this true? Because we already decided from the picture that to the right of the line is true. So what would make this true? And it would be less than or equal to, right? Because the line is solid, so we have the equal to, and 0 is less than 2, which makes the point true. So we're going to put a less than or equal to there. Cool, let's get the dotted line. So the dotted line, the y-intercept is -3, and the slope, let's do up 1, 2, and over 1. Look, up 1, 2, over 1. This one's like reverse. Up 2, over 1. Up 2, over 1. And because we went over to the left, it's negative. Right? And if you take a look at this line, if you were going left to right, if you were walking down this line, you would be walking down. I said down. So it is a negative slope. All right, now we just have to decide what inequality symbol goes in there. So this one is shaded to the left of the line again. And pick any value to the left, and it should hold true. So let's pick negative 2 comma 0. I'm going to plug in, 0 for y and negative 2 for x and see what makes it true. So we're going to end up with negative 7, right? Negative 2 times negative 2 is a positive 4. 4 minus 3 is 1. Let's erase this. We're going to have a positive 1. There we go. Negative 2 times negative 2 is 4. 4 minus 3 is 1. So what would make this true? And it should be just less than, right? 0 is less than 1. And it's a dotted line, so it's just that less than. We're going to plug that in there. So these are our two equations. Now this is where we can use the calculator to help us confirm that we did it correctly, and we can match it up with the picture. So let's go close these out, and we'll put in the inequalities that we believe it to be. Less than or equal to 1/2 x. Oops. 1/2 x. Make sure you arrow over and get out of that fraction. Plus 2. There we go. And then y is less than negative 2x minus 3. Here we go. And we're just going to sort of, okay, hold on. I need to equal to here. There we go. We're just going to match it up with the diagram. We have negative 2 and negative 4. Perfect. Negative 2, negative 4. And this one goes through negative 3, right? Yep, right there. Awesome. And where they overlap is the triangular region at the bottom left, which matches up with the picture. All right, let's try the second one here. So, we have a vertical line. This vertical line is going right through negative 3. Remember, vertical lines always have the x, because no matter what the y value is, x is always going to be negative 3. So now we just need to decide what symbol is going to go here. So if you look, that shaded area is to the left of this line, right? And we can pick a point. We can pick negative 4 if you want. Negative 4, 0. And if this is true, that should be true, right? Because it's shaded to the left of that. So if we were to plug in the x, then we would get negative 4 something, negative 3. What would make this true? And it would be less than, right? Less than or equal to, because that is a solid line. If you look at a number line, here's negative 3, here's negative 4, here's 0. Negative 4 is further away from 0. It's to the left of negative 3, so negative 4 is less than negative 3. And because the picture shows the shading to the left, that means that point should be true. So this is going to be less than or equal to. All right, let's do this one. The y-intercept is a positive 2, and we start there, plus 2. And then the slope we're going to have, let's see, maybe we'll try to get from that point. I don't know, these are very clear to me. So up 1, 2, 3, 4, 5 over 1, 2, 3. So up 5 over 3. We'll double check that. 1, 2, 3, 4, 5. 1, 2, 3. Perfect. And the line is going up from left to right, so it is positive. Now the shading happens here to the right of the line. So any point we choose over here should make it true. I'm going to pick 0, 0. So let's see what happens. If we plug in 0 here, that goes away, right? And we'll just have 2. So what would make this true? Remember, we picked a point that should make it true. 0 is less than 2, right? And it's not, there's no line because it's dotted. So this is going to be less than. So there's our two inequalities. Let's take it to Desmos and see if our work paid off. If it is true, it matches the diagram. All right, let's close these out. X is less than or equal to -3. Perfect. Yep. And then the second one, I wrote that one down. Y is less than 5/3 x plus 2. There we go. And it's dotted, and the answer is going to be this triangular region down here at -3, 3. That's pretty cool that it tells you that. -3, 3. There it is. It does, in fact, match up with our picture. You don't have to do that last step. I just think it's nice to just confirm that you do have the right inequalities. Sometimes maybe you missed a line in your inequality. I mean, I did it. You saw sometimes maybe you have a sign wrong, a negative instead of a positive. So just matching up those visuals can really help. So here's two more examples. We're going to graph the following system. So at this point, you guys have so many ways to do this in your toolbox. You can use the slope-intercept form. You can use the x and y intercepts, right? You can make a table. You can plug in values. You can use your calculator. So let's take it to the calculator at this point with the graphing. We're going to go to Desmos. This is really good practice. You guys have this tool, so I need to show you how to use it for sure. So it's y equals less than. Remember, you can just type it on your keyboard, or you can even click here and pop this keyboard up, and it will give you these options as well. Whichever you prefer. There's the first inequality, and the second one is greater than or equal to -2x minus 3. There we go. So some helpful bits when you're graphing is to see where it crosses those axes. So at 0, -3, and then -1.5, 0. Woo. 0, -3, and -1.5, 0. There we go. That's the bottom line. That's the red one. So it should be, look at that. It should be greater than, not greater than or equal to. There we go. I have two different, I'm working in two different tabs. So we're going to have a dotted line. That was the second one. I'm just going to graph the top one by hand. Up 2 over 1, right? This positive 2. And that one is solid because it is also equal to. Now let's see where the shading overlaps. It overlaps to the right here, that huge area. You can turn them off if it's hard to see. See the black one is shaded to the right, and the red one is also shaded to the right. So I'm going to only graph the solution, which is here, the part where they overlap. On the SOL, they might have a question like this and ask you to shade the solution. So make sure you're shading only the area where they would overlap. I know that on our pictures that we did earlier, I showed you guys both because I wanted you to see. Here, I'll show you like these. Remember, we showed each individual and then we looked at where they overlapped. So just read the question carefully. They might want you to shade everything, or they might want you to shade just where they overlap, like in here. All right, here's one last example of going in reverse, where you go from the picture to the system. So these are both solid lines. Let's do this positive line here first. It's going through -1. That's an important piece of information. That's our y-intercept. And then our x value, we're going to go up 1 over, let's see, up 1, 2, 3 over 1. So it is 1/3. The line is going up from left to right, so it's a positive 1/3. Now let's decide which way the shading is going and what our inequality symbol is. So the shading is going to the left. Let's pick a point. to the left, 0, 0. I like it. So I'm going to plug in 0. Remember, since this is in the shaded region, it should make it true. So is 0, or what would make this true? 0 is bigger than -1, right? Bigger than and equal to, because the line is solid. So it's going to be greater than or equal to for that first line, number 1. All right, let's do number 2. This line is going through a positive 2. That's the y-intercept. And then we need our slope. So this line is going down from left to right. So we're going to go down 1 over 3. Down 1 over 3. Down 1 over 3. The over meaning it's a positive 3 to the right. Down 1 over 3. So again, this one is shaded down, and 0, 0 is in the shaded solution. So let's try it. So this would be a positive 2. And since it's in the shaded area, it's supposed to be true. What would make this true? It would be less than or equal to 2. 0 is less than or equal to 2. Cool. So it's kind of like a puzzle. Here's our two inequalities. Let's take it to Desmos. We just want to confirm. And thanks for hanging with me. We're almost done. If you see in your notes, this is the last one. I just have a few things to share with you guys before we move on. So let's look at Desmos really quickly. Y is greater than or equal to 1/3 x minus 1. And then the second one is less than or equal to negative 1/3 x plus 2. All right, let's just make sure this matches up. You can see a really important step is graphing them on the Desmos calculator to see if there might be any mistakes. And I see one. Hopefully you guys do too. Here, I said up 3 over 1 and I wrote 1 over 3. You guys see that? Here we're going to start down here. We're going to go up 3 over 1. So we're just going to fix this. Up 3 over 1. It doesn't change the solution to the shading, right? Because the slope would disappear anyways, because 0 times 3 over 1 is still 0. So that's going to fix our graph right here. Here we go. That looks much better. You can see that the solution is where they intersect there to the left. All right, so I don't know if you guys noticed, but I put like an additional Unit 3 review in OMHS. So usually the unit reviews say like, review your notes and review the lessons, and that's all good too. So if you wanted extra practice, I did put an actual review right here as a PDF, and there's an answer key, so you can look at that before you take your Unit 3 test. And of course, reach out if you need any help or you have any questions. Ms. Jadala has those extra sessions on the schedule this week. You can look ahead at your calendar for those. Thank you guys for coming. I'll see you in class tomorrow. Bye, everybody.